Good morning. How is everybody doing today? It's kind of a gloomy day outside. At least it's raining in my neck of woods. I would imagine it is or has been raining in your guys' too. I can just imagine during these days, some of you are still sitting in bed listening to me. I mean, not probably the best of environments to learn in, but I've learned to give that hope up of maturity a long time ago. But that's completely your guys' choice. Okay, for the most part, I think most of you have been doing very well with the situation that's been presented us. All right, I have been having internet troubles of late, so let me know at any time, okay, if I start sounding like a robot. Okay, please tell me, or if I start cutting out, okay, obviously speak up. Okay, I went yesterday and I have one class that never says anything, and I kind of cracked a joke this morning during my help class that it's kind of become, to teachers, socially acceptable to talk to yourself. I just sit over here and I just talk to myself, just crack jokes up, laugh at myself, and it's just the norm anymore. But okay, what we do for you guys. So I will be starting a new unit. Okay, today is day 1 of rational functions. Okay, I have had some technical difficulties already this morning trying to help those of you out that never went and got the packet at the beginning of the year. This thing is frozen on me right now, trying to print out just a certain page of it, and it is not working. I'm going to hit Control-Alt-Delete here and see if I can just kill that app right now, but I don't know if it's going to work. We'll see. It killed that app. All right, so option 2, okay, is those of you that do not have the packet, okay, well, you're going to have to write fast anyway, okay, and you're just going to have to get it from my screen. Okay, I'm just curious. I have not told out there how many of you never went and got the packet, but go ahead and own up to it right now. So I have an idea. Who does not have the pre-calculus packet? Okay, they forgot, didn't know, go get it. Okay, put that in there so I can see, okay, who those couple are. Okay. I don't know if you have a printer or not, you 3. If there's more than 3 of you, then kind of nice to know. Okay, but you are more than welcome to always print the whole thing out, okay, in general, okay, for yourself. Okay, this is what it obviously should say right up there in the first page of it. Okay, I'm going to try this one more time to print out. It's like page 64 is what we're going to be doing if you're going front to back here in just a second. Okay. We're going to be doing 4 pages worth of it, 64 through 68. I'm not going to print it there. All right, Adobe PDF. Oh, I got a little bit further than it let me go last time. Sorry, the things that I get excited about are pretty lame these days. It didn't want me to do that last time. Just a second. Wait for it. Wait. Well, you don't have to wait for anything. I'm just trying to get this posted to All right, I think I could be able to get that to Canvas now. Okay, it appears possibly. Okay, that this document right here, okay, those 5 pages that you see me going through right now are the ones that we're going to work on. Okay, but in the meantime, we're going to take the easiest quiz you have ever taken. Okay, right here. Okay, to start off with. Okay, it has, I think, 11 questions on it. Okay, and it should take you, okay, about 2 minutes to do. And it is timed, okay, on there. So I will have, okay, a timer on there. Okay, and this is all a speed quiz. And you will find out why, okay, in a little bit. Excuse me.
Is this going into the grade book?
I don't know. I probably not. But if I say no, um, see what happens is I have a hard time in class getting kids to sometimes do things if I say no. So if I say no before I give it, I don't even know if half of you will even try. You'll just put answers in there. So I'm not going to tell you. So you guys all give your best bet. Okay, but once you see it, you'll see why it's not a bad one anyway. All right, the code is 6982. 31. I'll put that in the chat box. 69, 82, 31. And I'm not trying to be mean by saying that. I'm sorry. Okay, it's just a hard situation that we're all in here. And it's always, sometimes we always have to watch out for that 1 or 2 bad apples. And I forget that the rest of you are not that way. Okay, at least I don't forget. Okay, I try to watch out for those that are trying to cheat the system more than learn from the system. So I wasn't trying to be a smart aleck when I responded to you. I hope you understand. All right, here we go. Let's have some fun. All right. So, okay, what was the part that we missed the most on there? Okay. Just want to kind of check out here. We're missing some common questions, okay, that were on here. Okay, but the biggest thing that okay, I'm going to throw this over here. Okay, and you guys need to speak up because the biggest part, okay, that I will say, and I'm going to say this with hopefully understanding, okay, that the hardest part about pre-calc is your foundational skills, okay, and you can make excuses and say, well, you know what, some of you use a calculator to do everything, okay. If it says 5 plus 3, I have watched my own kids type 5 plus 3 into the calculator, and yes, they get an earful from their mom and dad since we're both math teachers, okay. It's just not being lazy. We're all that way, okay. But being able to come up here and add fractions, okay, being able to come up here and find the product of two things to multiply them, to be able to write things in simplest forms, okay. You can see being able to multiply these right here into simplest form. I had 11 people not be able to multiply fractions, okay. So
I know for me, the time limit on it like started running down and like it just flusters me to click a random answer. So I don't know if maybe somebody else had that problem too.
okay, and I did that on purpose, okay, because I put the time that's there because there is some issues of how fast are we at these things. And if you look back, maybe, and I'm not going to grade these, but if we look back at, I don't know, when you guys were in elementary school, you guys remember the times tables test? Okay, and you guys did those, and yeah, you hated them because you had to get fast at them. But your foundational skills, in order to do anything, those are things you have to just be able to look at and do quickly. Okay, so yes, okay, when that timer was going and I only gave you so long, okay, you just started clicking on things. Okay, well, that in itself is telling me that our strength of just these foundational things, being able to divide. I got half of us don't know how to divide fractions, or maybe like you said, you started clicking on things. Okay, an algebra skill right here of just being able to multiply and not know how to deal with exponents. Okay, this one got a little bit more complicated, and man, I got more people got the hard one right. Okay, right here. Okay, dividing right here, dividing fractions, that's a very quick one. All you have to do is subtract the exponents. Okay, so that was a very, very simple one. Okay, this one right here, all you have to do again is you subtract your exponents. Okay, when going about to do it. Okay, and I will kind of go over a lot of these things, but how can I teach the pre-calc if you're not for sure how to add fractions, how to multiply fractions, and do those things like that? And then that's the main reason why I came up here and I did this quick little assessment, and I'm going to give it again. Okay, I think on Wednesday. Okay, and again, I'm going to put a timer on it and see how much better we do on it. Okay, at that point. Okay, and I get it. Okay, I do understand. Okay, I give this every year, not as a quizzes is, but I do it in class every year, and it's the same concept. Okay, so it's not just you guys. Okay, it's a concept that, okay, we have come to the reality of I can use my calculator for everything. Okay, and why should I have to learn this when I have a calculator? Okay, well, the foundational skills of what we're going to be doing, okay, as we continue into pre-calc are going to need a lot of, okay, strong foundations of, do I know how to add? Do I know how to subtract? Do I know how to multiply? And do I know how to divide? Okay, So any questions, even comments, you go ahead, let me know. All right. So, okay, multiplying and dividing rational functions. Okay, so we're just going to start with the multiplication and division of, okay, fractions. Okay, so just so you guys, and you can tell me if I don't need to cover this. Okay, but if I have 2/4, okay, plus 1/4, this is where you had to find common denominators. Okay, so that you can come up here. Okay, whoops, I meant to put this as 4. Okay, find common denominators of 8/12, okay, plus 3/12 is 11/12. Okay, multiplying. Okay, if I had, let's say, 2/3 times 9/12. Okay, now some of us were actually multiplying. Okay, you just multiply straight across, but when you were given time, okay, and time was an issue, you should always cross cancel, okay, first, okay, which gave us 3/6, which reduced down to 1/2. Okay, and then finally, if you're dividing fractions, okay, I don't know if anybody was ever, okay, taught this little saying here, but dividing fractions, that's my cry, flip the second and multiply. Okay, well, if you have ever heard of that, then you take and flip this second one. Okay, so it just reciprocates, so you multiply by the multiplicative inverse. Okay, and that's what the mathematical statement is right there. So I just flipped the second fraction, cross cancel, okay, cross cancel, okay, and my answer here would have came up just a 6. Okay, so that's the very, very basic foundations, okay, when we're coming up here and we're multiplying. Okay, another basic foundation skill that we should have had is when you multiply variables together, and this is a pre-algebra concept. Okay, you should have came up here and learned, okay, that we have to add the exponents together. Okay, if you have a power to a power, okay, what that really means is x to the second times itself, okay, 5 times, that's supposed to be a time sign. Okay, whenever you take something times itself 5 times, well, that's going to give us a total of 10 of those x's right there. So the fastest way to do that is when you have a power to a power, okay, you're going to multiply, okay, those things together. Okay, well then obviously if you're dividing things out, if you have x to the 14th, okay, over x to the 3rd, okay, well, x to the 14th, I don't know why I picked 14 of them here. I knew I was going to do this out longhand. 5, 6, 7, 8, 10, 12, 13, 14, over x to the 3rd. Okay, well, this x right here is going to cancel out with that x right there. That one right there cancels out with that one there. That one there cancels with that one there. And it looks like we have 11 of them left, because the shorthand way when you're dividing is to subtract them. Okay, and that's what I came up with. Okay, right here is x to the 11th power. Okay, how do we go about using that in what I was doing right over here? Okay, if you're going to come up here and you're going to divide your variables right here, it's just like I got done doing. I have 3/2 to the x to the 7 minus 4 power, which is x 2, or 3/2 x cubed, or 3x cubed over 2. Either way, the one thing that we are going to say here, though, in this part is we're going to talk about what some of the restrictions are to the variables. Okay, what I mean by restrictions is there are some values that x can and cannot be up here. And if in this original problem, if I was to have, that's supposed to be an x right there, x to be 0, sorry, this is not writing very well. Okay, if I was to put x in as 0, I would have in the denominator, I don't really care what's in the numerator right now. Okay, but in the denominator, I would get 0 for an answer. Okay, and this is another little basic foundational answer is, okay, if I have 7 divided by 0, can anybody tell me what you get when you take 7 divided by 0? You guys still awake out there? Did I put you to sleep yet? All right, Brady says undefined. Okay, well, the answer is either 0 or undefined, Brady. So let's take a look here at, okay, what you do when you divide. Okay, well, when you divide, you got to find out what number will go into the numerator. So 10 divided by 2 is 5. Okay, if I had 14 divided by 7, well, 14 divided by 7, what number goes into that? Okay, well, 2. Okay, so in this case right up here, 0 right here, I meant to put a times sign here. I don't know why I put a divide sign. And it's supposed to be a times. Okay, 2 times 5 was 10. 7 times 2 was 14. 0 times what gives us 7? And Brady, you're right. That is undefined. Okay, now if I switched it around and I did it this way, 0 divided by 7, is that undefined? Brady says 0 again. You guys agree with him? He has not again, but he says 0. Are the rest of you awake out there? Again, Mr. Johnson's.
Yes.
All right, good. Okay, so this is where I'm talking about. Okay, yes, 7 times, excuse me, 7 times 0 is 0 right up here. So yes, he is correct. Okay, you cannot divide by 0. That is a number 1 rule, and that's where I was at on this last one right here, is I was talking about a restriction for the variables. And a restriction for the variables right up here is x can be anything up here, and we're not solving it yet. We get towards the end of this chapter, we start solving rational expressions, or in this case, they're called equations. Okay, but right now we need to learn the foundations and just how to simplify things. Okay, but the one restriction that we have on the variable x is that it cannot be equal to 0. Okay, now, sometimes our variables are not just as straightforward, okay, as this right up here. Okay, and here is again one of my pet peeves. Okay, again, a pet peeve is something that drives you crazy. Okay, here's my biggest pet peeve, and you will see me say this one over and over again. Okay, because when I see a pre-calc student do this, okay, it's kind of like fingernails on a chalkboard. Just hear yourself listening to that sound right there. Do you guys love that sound of fingernails on a chalkboard? Maybe you guys are too young to even know what a chalkboard is, but this drives me absolutely insane. Okay, to square something and not to know to FOIL it, okay, by the time people are in pre-calc, okay, is, okay, not one of my most favorite things to see a pre-calc student do. Usually, you know, they don't like to see it either because I don't give them very good partial credit. Well, here's even a worse one. Well, maybe it's not worse because that one is the worst. Okay, is somebody having absolutely no algebra concept of how to simplify, okay, this problem. Does everybody understand that that is absolutely incorrect? Okay. What do I do? Not that. Okay. Orders of operations, okay, tell us that that was completely violating orders of operations. That is like doing this, and I will show you why you couldn't do that. 7 plus 3 over 7 plus 1. All right. I think all of us know the answer to that is 10/8, which reduces down to 5/4. But watch what I would have a student do. 7 divides by 7, and the answer is 3 over 1. Okay, what did I do? Well, I violated my orders of operations. Okay, what do I mean I violated my orders of operations? Well, obviously, you have to simplify the numerator first and come up with 10. You got to simplify the denominator second and come up with 8. And then, yes, that does reduce, okay, to 5/4. Okay, so this canceling out thing that I did right there, okay, I hope you realize that when you're doing fractions, that is not very smart. Okay, that's why this, okay, canceling thing that I'm doing right over here is not very smart. Okay, but instead, okay, how do I go about solving this one? Well, you come up here and factor. That's what this whole chapter is going to do and challenge you, is you're going to have to become good at factoring. Okay, so I came up here and I factored this x squared minus 2x minus 3. I factored it down to x minus 3 times x plus 1. Okay, I factored the x squared plus 5x plus 4. I factored that down to x plus 4. And then I noticed, okay, I can cancel. Okay, if I came up here and I change, and some of you are saying, well, how do you cross cancel over here now and you couldn't cross cancel in this example right up here? Okay, let me change my example to a multiplication sign. Here you go. I will explain to you exactly why this works, because this right here is all one operation. That is multiplication and division. Please excuse my dear Aunt Sally. Do you guys see how multiplication and division are worked together as one? Okay, yes, this right here is 21/7, which is 3. Okay, well, that's because you can come up here and you could cancel out those 7s right there, okay, because they factor out, they divide out, okay, because multiplication and division go together, whatever comes first, left to right. Okay, but in this case right here, I have, okay, a times here, and I have a times right there, which allows me to cancel out, okay, those x plus 1s. My final answer is x minus 3 over x plus 4, and the restriction that I have on this is what could x not have been? Okay, well, if I came up here and I was to put in, okay, -1 into this problem. Okay, so if I came up here and in my problem, I was to substitute in -1 into the factored out problem, meaning I put a -1 in there and I put a -1 in there. Well, notice what happens right here. -1 plus 1, well, that's 0. 0 times 3 is 0. I don't care what I have in the numerator. You go ahead and plug in your -1 up there. Looks like I'll get -4, okay, times 0. It doesn't matter what's up there. You can't divide by 0. That's because -1 is a restriction. Okay, it makes this function undefined. Okay, -4 would also do the same thing. Okay, when I put in -4, okay, in right there, this part, that kind of is a mess there, but that part right there becomes a restriction of 0. I think I have it well defined here next on this next part right here. I did the whole thing in there, and I did it to the original one, not the factored out one. And you can see right here that it doesn't matter what the numerator is, but when that denominator, you can see right over here in this one, I got 21 up there. But the big thing that I have right here is that 0 in the denominator makes both of these functions undefined at that spot, okay, creating, okay, when we graph it, okay, creating a hole or an asymptote when we went about graphing it. On a scale of 1 to 5, okay, let me know if you're awake and understanding what I'm going on over there right now. Okay, put that into the little text box over there so I can see that you're actually following along and I'm not talking to myself. All right, so we got some 3s and 4s. Does anybody have any specific questions for me? Anybody want to comment what part needs to be highlighted and talked about a little bit more? Anybody want to help Mr. Johnson figure out how to get those 3s up to 5s?
I think we just need to work on them. Like
some more problems. All right, I can do that, guys. So we're good. Okay, so you're just not confident yet, then that I can get. Okay, if what I'm saying is, you know, like really, really foreign to you, okay, then I just was worried. Okay, so, okay, doing this next problem right here, to simplify this one right over here. Okay, well, there is a new concept here of, well, there is a common factor that I could factor out of this right up here in the numerator. Okay, and that greatest common factor, well, the first thing I factored out of it was a -1. Okay, that factored a -1 out of that part right there. That came up with my x squared minus 2x. Okay, then, okay, no, you can't just come up here and start doing that junk again. Okay, so you got to get that out of your head. But in the numerator, okay, they actually, you don't have to factor it into 2 binomials because there is, okay, what we call a greatest common factor. And these greatest common factors are like our superheroes. Okay, they are going to swoop in and save our day. Okay, and if you're in my algebra class, okay, you'd actually understand how I sometimes get a little bit carried away with the greatest common factor boy and, you know, double parenthesis girl, and never mind, I'm not going to go into that story. Okay, I probably will, but anyway, okay, I came up here and I factored out, okay, an x out of this right here. When I factor out an x, I'm left with this x minus 2 right there. Okay, that's, okay, what I have right there. Okay, and that allowed me from there to come up here and cancel. Okay, this x minus 2's, cancel those things out. And what am I left with? Well, I'm left with a -x in the numerator and I'm left with an x plus 1 in the denominator. Okay, well, what are my restrictions though? You got to make sure you tell me what can x not equal. Once you simplified it down, what am I not able to have x as? Well, I can't have x as -1 because if I plug it in still now, I'm going to get 0 in the denominator and that makes everything blow up. Not literally. Okay, but, okay, it makes it undefined. What else could x not be, even though I crossed it off? Okay, if I would have had, okay, put, okay, in here a 2 into this part right up here, I would have came up with x in the denominator. Here's all my work, okay, that I did, but they did it as a calculator, okay, work for you right here. They came up here and they graphed it, okay, and they saw that when they graphed the function right there, they came up with an error at -1, okay, because when we graph it, okay, that was what we're going to have is when we actually get to these graphs next semester, okay, if we actually get there, okay, it's going to be called a vertical asymptote, and these things that crossed off are going to be called holes, okay? So that's just part of a graph that we have. So if I was graphing this thing, okay, this is kind of what the graph, it looks kind of like an inverse variation graph, okay, like this, that we did, okay, but there'll be a little hole, okay, and this you don't have to know yet, so I guess I'm just bored and want to torment you some more, but there'll be like a little hole in the graph at 2, like that, okay, and then there'll be a vertical asymptote, okay, a vertical asymptote is something you get close to but never touch. Okay, but did you guys get vertical asymptotes? Talk about those in inverse variations? Yes? No? Yeah? All right. Okay. So I thought you did. Okay. All right. There we go. I just talked about that one right there. All right. Okay. Here we go. Multiplying this one out right here. Okay. So how do I go about doing this problem right here? Well, the first thing that I'm going to simplify here is I need to cube each one of these. I'm going to have 2 to the third power, x to the fourth, that's supposed to be a 4 right there, x to the fourth to the third power, y to the negative fifth to the third power, okay, all over 3x cubed times y to the fourth. Okay, so I just simplified this part of it. I ran out of space here. Okay, and then I'm going to come over here and I wonder if I can clone this thing. Oh, cool. Okay, I'm going to come over here and multiply, okay, this part, okay, right over here. Okay, multiply that out right there. Well, simplifying this first part right over here, 2 to the third power is 8. Okay, when you do a power to a power, we multiply them. Okay, we multiply them, y to the negative 15th, all over 3x to the third, y to the fourth, okay, times 15x squared all over 8x to the negative third, y to the second. Okay, well, to summarize your Algebra 1 division rules, okay, remember when you divide, you are supposed to subtract, okay, your exponents. And anytime you come up with a negative exponent, okay, you're supposed to reciprocate that by putting it into its denominator. Okay, well, one of the dumb mnemonic devices, and mnemonic devices are stupid little things that I sometimes will use to help students remember things, okay, is, okay, if I was to simplify this problem right here, okay, and I wanted to reciprocate this, okay, well, this simplifies to x cubed all over, sorry, that's supposed to be a z to the 7th, y to the positive 5th, because this reciprocated itself and went down to the denominator. Okay, so always my dumb mnemonic device when I taught this in Algebra 1 and 2 was, okay, when powers are negative, okay, in order to make them happy and become positive people, we will always move them in the opposite direction on the numerator or denominator as they want to go. Okay, so in other words, if I had x cubed, y to the negative 7th, z to the 10th, all over, okay, x to the 10th, y to the 3rd, z to the negative 4th. And I was to simplify this part right here, okay, I always look at this as being an uptown, downtown fight. Okay, there's 3 x's in the numerator, and there's 10 x's in the denominator, and they're going to fight one another. Okay, this is like an uptown, downtown war. Okay, and, well, the uptowners get all killed, but they do fight and leave 7 people downtown. Okay, well, the Y's, they're not going to fight just because, well, the Y uptown is just not happy because he's negative right now. In order to be happy, he just says, well, I'm going to come downtown and I'm going to live with you Y's. Well, when he does that, he adds together, okay, with his Y downtown, and he becomes 10 of them right down there. Well, the Z's are not happy, okay, because there's, okay, 4 of them that are downtown right here, okay, and he says, well, I'm going to move uptown with you, okay, and I become, okay, an answer here, okay, of Z to the 14th. Okay, so there's my final answer right here. Mathematically, this is what your mathematicians would say in your textbook. Okay, if you can still see what's underneath all of that garbage, this is what they tell you to do. X to the 3 minus 10 power times y to the negative 7 minus 3 power times z to the 10 minus negative 4 power. Okay, what does that simplify to? Well, this part, okay, right here simplifies x to the negative 7th times, this is y to the negative 10th, and this is z to the, well, double negative right here turns it into 14. Okay, well, what does that finally simplify down to? Well, like I said, this one right here goes 1 over x to the 7th times 1 over y to the 10th times z to the 14th. It's supposed to be a 14th power, sorry. Okay, I can put that over 1. And yes, I come up with z to the 14th, okay, all over x to the 7th, y to the, that's supposed to be a 10 down here. Okay, my stylus little cushion thing on the end is, I think, starting to rip or get, I got to buy a new one. Okay, it's starting to get bad. Okay, and I have bad enough handwriting as it is. Okay, so where was I at? Okay, I was back here on this problem right here. And if I go about simplifying this problem right here, and here we go, here's my dumb analogy. Okay, you can take it for wherever you like, or you can just do the flat out math, 12 minus 3. Well, I like fighting. Okay, so I'm going to take 3 of these x's and I'm going to fight with the 12 up there, and oh yeah, 3 of them die out and I'm 9 of them there. Oh, these y's just aren't happy? Let's move downtown. There's none of them here, but as I move downtown, oh yeah, there's 19 of them down here now. Okay, and I look over in my next little example right over here. Oh, these x's right here aren't happy. Well, then let's just move uptown right here. So there are none here, and I move uptown and I say, oh, there was 2 uptown and there was 3 downtown. So now I have an answer here of 5 of them uptown. Rewrite, what do I have here? I have 8. X to the 9th. Okay, all over 3. Okay, all of these 3's died, so there's none there. Okay, they got killed out in the little mathematical war. Okay, times, okay, 15. Okay, x to the 5th. Okay, that's the x to the 5th right there. Okay, all over 8. Okay, y to the 2nd. Okay, well, where does this go from here? Okay, well, I can still have a little bit of fighting going on here. Okay, because, well, actually, okay, it looks like the x's are all in the numerator right up here. Okay, but there is a little bit of a fight here that can happen because this 8 and this 8 right here, they can cross cancel each other out. Okay, giving me 1 and 1. Okay, I can also cross cancel my 3 and my 15, giving me a 5 and a 1 right there. So what am I left with? Okay, right here, as I simplify it, okay, looks like I'm left with in the numerator 5, but I have x to the 9th and x to the 5th. Okay, when I multiply those together, I add my exponents. So I have 14 x's in the numerator left over. Okay, I have y to the 19th, that's a 9 right there. Okay, and y to the 2nd. Okay, I add those together and I get y to the, hold on, my computer just did something funny here. It won't let me write. Are you guys still able to hear me out there?
Yeah.
All right. Okay. And I come up with a final answer of, okay, look at all that stuff. Okay, so I came up here and I had to simplify, okay, all of these things right here down, okay, by doing, first of all, I did all my powers. Okay, I distributed all my powers, power to power. I had to multiply my powers together. So that's the first thing you got to remember about Algebra 1. Okay, second thing you got to remember about Algebra 1 is, what does a negative exponent do? Okay, well, a negative exponent means that you reciprocate it. So basically, yeah, I just brought it up into the numerator and added it to the x's that were already there. That's where I said, oh yeah, I'm just going to make it positive. Move to the numerator, add it to the ones that are up there. And then I had my wonderful fights, my up, down, downtown fights. Okay, well, that means basically, what do I mean by a fight? That means that if I had x to the 7th, okay, over x, okay, to the 3rd, okay, well, yes, that's 7 minus 3 because the 3's downtown, there weren't as many 3's downtown, or the x's downtown as there was uptown. Uptown, I mean numerator. Downtown, I mean denominator. Okay, and the numerator is going to win out, but people do die uptown. Okay, and that is just a subtraction, okay, of things. Oh, my computer is spinning again. Sorry. There we go. All right. Questions there? All right, the last part is the restrictions. Okay, so, and I had too many screens here, so I'm going to have to come over here and I'm going to look at what are all the possible restrictions that could not be in the denominator right over here. One of the restrictions is, well, x. If I ever had x is 0, that would actually make this denominator, because I could put 0 in here, and 0 times 3 is 0, 0 times whatever y is 0. That would make that denominator be 0, and it ended up making the whole fraction 0. So no, you can't have x to be 0, and you cannot have y to be 0. All right, are you guys still awake back there? All right, I can either do one more for you, or I can have you start doing some of your practice problems, okay, that we have right over here. Okay, here's the one more that I want to do that has some more factoring things in it. Okay, but okay, I will let you determine right now, what would you like to do? Practice or one more? I've talked a long time. Put it down. I try not to talk this long. I got 4 one mores. I got 1 on our own, and I got the rest of you I put to sleep. If you don't care, then said don't care. So I know you're not sleeping back there. Everybody needs to make put something in the comment box right now. Go. Put something there. Even if you want to put it in there, Mr. Johnson, you're the coolest person ever. Put it in the chat box. We all know that's true. Who do I not even have out there still? I'm going to start calling on people. You guys are killing me right now. I can't even answer this right here. Go through the chat window here. Jameson, give me what you think. Ethan, type in what you think. Okay, please, everybody, type in. How do I know you guys are even listening right now? Don't make it difficult, please. Okay, otherwise I just keep on talking and it gets, you guys make it difficult for me. Sometimes it makes it hard for me to justify all my efforts. Okay, which I will always go the extra mile for you, but okay, you gotta stick with me. All right, so on this first problem right over here, okay, I factored a GCF out of the denominator. Whoops, I didn't even put a time sign there, or an equal, I meant to put a time sign. Okay, so I have, okay, a time sign there. Okay, now I do notice right away, and I can do this right away, that this x plus 4 and this x plus 4 right there, they're going to cross cancel, just like when I was multiplying fractions together. Okay, if I had a problem I'll go over on this screen, and I had 2 times 5 times it by 10 over 11. Okay, well, you should not learn to just multiply straight across. You should always, okay, have reduced cross canceled first. Okay, so that would have gave us 4/11ths when you were timesing normal fractions together. Okay, well, that's why I canceled out those x plus 4s right here. Okay, but the one thing that you do have to recognize is that we do have to factor. Okay, and that is a perfect square up there. Okay, it is actually a difference of squares. Okay, what I mean by a difference of squares, okay, is that x squared minus 4. 4 is a perfect square right here of 2 times 2, and that does eliminate my insides and outsides of 2x and negative 2x. Okay, so again, some of this stuff, again, may not be the pre-calc that's going to cause the biggest problems, but, okay, noticing that, oh, how do I remember I was supposed to factor that? I don't know. We're supposed to be good at that from Algebra 1. Okay, and we're in pre-calc now. Okay, so how do I know how to multiply and add fractions? I don't know. Maybe that's a recommendation or something that probably, you may need practice on, or, we need to go through and review. Okay, so I do have something else that will cancel here, though. Okay, I see this x plus 2 right here. Okay, that will cancel out with this x plus 2 right down here. Okay, and all I'm left with is when they cancel out, you are left with 1s. Okay, just like if I cancel out down here in this problem right down here, a 5 divided by 5 was a 1. Well, an x plus 4 canceled with an x plus 4, I'm left with 1. Okay, and if I multiply my numerators together right here, I get 1. If I multiply my denominators together right here, I get 3 times, well, I still have this x minus 2 here. Okay, so there's my answer, 1 over 3 times x minus 2. But my restriction, which I have over here on my next page, is, well, 1, okay, restriction, okay, is this x minus 2. Okay, I know it cannot equal 0, okay, because this part right down here, if I put in a number in for x that would make that bottom become 0, well, what would make that denominator become 0? Well, x cannot equal 2. Why? Because 2 minus 2 is 0. 0 times 3 is 0. And I can't divide by 0. That is why 2 is a restriction. Okay, it makes all of that fail down there. What also is a restriction? Okay, well, if I came up here and even though I crossed it off, this x plus 4 was in the denominator right here. And it cannot equal 0 as well. So what that means is, okay, x cannot equal negative 4 as well, because if I would have put negative 4 in, okay, right over here for, come on, computer, switch colors. There we go. If I would have put a negative 4 in here, this would have came up with 0. 0 times 3 is 0. 0 times whatever you have over there puts a denominator of 0, which again is undefined. Okay, and later on we'll recognize that one, that's the 4 as a whole, the negative 4 as a whole on the graph, and the 2 is a vertical asymptote on the graph. Okay, and that's why the restrictions are undefined at those spots. Okay, any questions there on that one? So my answer, okay, was 1 over 3 times x minus 2, okay, where, okay, x cannot equal 2 or negative 4. There is my answer. All right. Now it's your turn. Okay, so, okay, if you are in this packet right here, page 64, is where I thought it was. We're going to do some of these problems that are going to be right here. Okay, and while you do those problems, I'm going to post this to again, this is the rational function unit. Okay, I got it just working right now. Okay, so I'll get this posted in there if you want to pop it up and go from there. Okay, but there are going to be only a certain number of problems that I'm going to have you do from it. You don't have to do all of them. I highlighted them right here. So if you have the packet right now, go ahead and circle these problems right here. And then once you get those done, I'll put the answers up here for them and we'll go on to the next page. There's 4 of them on the next page we're going to do. Then I have the answers to those done and we'll go on to the next page. Okay, which are those right there. And then we'll go on, I'll give you the answers to them. And then we'll go on to the next page, which are these, okay, right here. And then once we get done with that page, okay, we'll get into dividing fractions, okay, a little bit more from there, okay? All right, so, okay, where are you at on multiplying? All right, your practice time comes from this page, okay, right here. I am in the process of trying to get this to the Canvas page. Okay, you have questions on any of these, you need to ask. Okay, we were at 3s, so by the time we're done with this, we all need to be at 5s, or you need to be advocating for yourself. Once I'm done posting here, I will put the answers up. We'll go to the next page. By that time, you should be able to circle all the ones that you have are supposed to be doing. You want to do them all, go ahead, but you don't, we're only doing certain ones. All right, the worksheet for today is posted. If you do not have the packet, okay, it is posted. All right, are we all ready for the answers for A, D, and G? Okay, here we go. Here's your answers. Okay, I factored a GCF out of A, which is X. I uptown, downtown fight those X and this X cubed that's down there, and I came up with X squared in the denominator. I had an X plus 4 up there. Okay, and I have a restriction where X cannot equal 0 in the denominator. Okay, on D, okay, did some uptown, downtown fighting here, and I'm left with 4y to the 4th all over 3x cubed z to the 4th, where x cannot equal 0 and z cannot equal 0. On G, I have a 5, which is my GCF I factored out of the numerator. I have a 4, which is a GCF I factored out of the denominator. Okay, and that simplifies down to 5/4, which then simplify, or where x is a restriction of -8. Questions are on A, D, and G.
I have one.
Yes.
How come in the second one for the restrictions, y cannot equal 0? Why is that not one of them?
Well, if I said I did that on purpose, I am lying, but maybe that's a good thing. I should put more errors in here, okay, in my answers so that you guys actually ask questions. But thank you. You should have that in there, okay? It should have been a restriction as well, okay, because it was in the original problem, okay, that I had right up here, not in just my ending problem. Good catch. Any other questions? All right, here's 4 more. Okay, A, C, D, and F. Now you get to test your abilities to factor a quadratic. Don't worry, we haven't even got to division yet. You know, you guys remember that back in elementary school when all of a sudden they taught you how to divide fractions and you thought that was the end of the world? Well, how about just divide in general? Some of you still don't long divide. This is like mathematical heaven for math teachers. Factoring, simplifying. I know, none of you are math geeks like us. Well, maybe some of you are, but you don't want to admit it. I'll be right back here just a second. All right, I'm going to have you go through and circle the rest of them because some of you may get done sooner than others. Okay, here, so go ahead right now and circle all the ones that I have. So the factoring expressions, we had A, C, D, and F. Okay, on the next page, do A, D, and F. Now, these are the minimal number of ones you need to do. You need to do, okay, as many as it takes for you to start to get it, though. This is the foundational stuff, okay, that you're going to see come back over and over and over again in pre-calc and calculus, if those of you that continue on. Okay, so you're more than welcome to do more of them here. Okay, and then on the next page, okay, GCF and factoring expressions, A, C, D, and E. Or sorry, B, C, D, and E. Okay, and then, hold on. And then factoring and multiplying expressions, A, B, D, F. A, B, D, F. Okay, and our last one that we have is when we get to dividing expressions, A, B, D. A, B, D. F, and G. And finally, I and J. Okay, so dividing, I have A, B, D, F, G, I, and J. Does anybody need me to go back and look at any of those pages? All right, I'm going back to page we were on then. I did record this, so you can always go back to the recording and catch the ones that I put there, and I'll put those into the assignment sheet on Canvas when we're done here. I'll put them into the assignment on which ones to do that I highlighted.
Can you go back to factoring plus multiplying expressions?
Factoring plus multiplying expressions. Factoring. This one?
Yep.
So A, B, D, and F.
All right, thank you.
You are welcome. Now, the key to this is don't just do them to get them done, but make sure that you're checking them as we go too. All right. Answers. So our first A, factored into x minus 2, x minus 1. The denominator factored to X plus 6, X minus 1. Now these X minus 1s, they do cancel each other out. And my final answer is X minus 2 over X plus 6, where X cannot equal 1 or X cannot equal negative 6. Again, in order, I didn't have a lot of space here. You take both of these denominators, set them equal to 0, okay, and say X plus 6 cannot equal 0, X minus 1 cannot equal 0. I did not have the space on this worksheet to do so, okay, it's just with writing in the pen, so I just wrote the restrictions off to the side. Okay, for C, okay, X squared minus 2X minus 5 simplifies to X minus 5X plus 3. The denominator is a difference of squares. X squared minus 9 simplifies to X minus 3X plus 3. These X plus 3's do cancel each other out, leaving us just with X minus 5 over X minus 3, where X cannot equal negative 3 and 3. Okay, and on D, okay, D, I factored this one out. Now, this one right here, there was a leading coefficient of 2. You cannot always just come over here and look at this last number and see, oh, which one of these numbers differ by 15? Not when the leading coefficient is not a 1. Okay, you have to check your insides, okay, and your outsides and see what's going to add together when to come up with 15. And you can see right here, my insides came up with 3x. My outsides came up with 12x. Okay, and 12 plus 3 does give me 15. That's how I got 2x plus 3 and x plus 6. Now my denominator simplified to x plus 6, x minus 4, noticing that my x plus 6's do cancel. Okay, and I'm left with, that's supposed to be a 2 right there. Okay, 2x plus 3 all over x minus 4, where, okay, x cannot equal negative 6 or 4. Okay, and the last one, letter F, I factored a GCF of 6 out of the numerator. That left me with x plus 5 times the 6. I factored the denominator, x plus 5, x plus 3. Okay, I saw the x plus 5's canceled each other out. Okay, and what are my restrictions though? My restrictions are going to be x cannot equal negative 5 and x cannot equal negative 3. Any questions there on those 4? Now, it's very hard for me to gauge how far you got before I started covering these things. Okay, but the one thing I can tell you is just like the quizzes is this is something that has to become second nature at. I got to be able to factor these things fast. I got to be able to do these things. Otherwise, when we start getting more of because this is actually an Algebra 2 topic that you did not cover last year, and we're covering it in pre-calc because it's a foundational skill you have to have. Okay, but it's a foundational skill that's going to be needed in order to not make your pre-calculus topics go forever, meaning your homework, your tests, things like that. You have to become efficient at them. Okay, very, very similar to, am I efficient at being able to add fractions, multiply fractions, divide fractions, do exponents on that quiz is. Okay? All right. With that, okay, being said here, I'm going to skip, okay, so that I have time to talk about dividing rational expressions. Okay, just like if I was to come up here and divide fractions, if I had, okay, let me get a marker that's a color, 4 over 9, okay, divided by, okay, I have 10 over 18. Sorry, my my stylus just ripped. So it is not writing very well, and I need to order a new one apparently. Okay. I have another one. Let me try this one. Okay. So if I'm dividing fractions, okay, one of the things that, okay, you need to end up doing here is you're going to be multiplying, okay, my, okay, 4/9 times it by its reciprocal, okay, 18/10. Okay, well, those things right there are going to cross cancel. Okay, these right here are going to cross cancel, leaving us with 2 and 5. And then we multiply straight across, and the answer is 4/5. Okay, well, what does that do when we're talking about rational expressions? Okay, well, I'm going to end up doing the same thing, okay, right over here with rational expressions. Okay, I have to take this division, okay, that you see right here, and I have to multiply it by its reciprocal. So I have to multiply this by its reciprocal. So I took the 16/9y to the 5th, times it by 9y to the 5th. Now I can come up here and I can say, oh yeah, I can cross cancel these 9s. Okay, I can uptown, downtown fight these x's right here. This x right here kills all the x's up in the numerator. Okay, this y right here, okay, can uptown, downtown fight with that y right there, killing it out. Okay, oh yeah, and this 16 over here fights with this 4 right here. Okay, the 4 dies and it left with a 4 down here on the bottom. Okay, and when it's all said and done, okay, I did all of that here with that crossing things off. Okay, all I'm left with is 1x in 4 y's in the numerator. So x, y to the 4th all over 4. That's what's all that's left in the numerator. Okay, where my restrictions, okay, are going to be, and this is where I need you to pay attention, x cannot equal 0, because yes, it cannot equal 0 there. Actually, this one you don't have to pay attention as much. Okay, y cannot equal 0 because of that y right there. Okay, but I thought I was going to have another variable over here that I have to watch that went in the numerator. That's not there. But there, and there's my restrictions, okay, for what I was going to have. Questions are on dividing fractions. I have one more good example that I thought I put in here, okay? But I must have left it in my other slideshow, which is this one, okay, right here. All right, so what do we do when we have a big long one like this? Okay, well, the first thing that I'm going to have is I'm going to take and change this to a multiplication. So I have x to the 5th minus 4x cubed. Okay, and again, this is not writing very well because my stylus ripped. X squared minus x minus 2 times it by x squared minus 1 all over x to the 5th minus x to the 4th minus 2x cubes. All right, so that's step number 1. Change multiplication or change division to multiplication. Okay, step number 2 is I want to simplify this. Okay, so I have to simplify it. The numerator has a GCF of x cubed. Okay, can't write without a stylus. Okay, and it's not like a pencil, I can sharpen it. Okay, x squared minus 4, actually, That should be x, yeah, x squared minus 4 all over x squared minus, actually I need to factor that bottom out. Okay, I'm too concentrated on my dang stylus right now. That's ticking me off. It's not writing. Okay, the denominator factors to x. Okay, minus 2x plus 1 times it by, that's a difference of squares in the numerator over here, x minus 1, x plus 1. Okay, all over GCF of x cubed. Okay, that needs to come out of here. Okay, I have x squared minus x minus 2. Okay, and there's still some things in here that need to be factored out. Okay, so I'm going to factor out of, okay, the numerator, I have x cubed times that x minus 4. That is x, that's a difference of squares. That's x minus 2, x plus 2. Okay, times. Okay, the difference of squares in the numerator here, I have that x minus 1, x plus 1. Okay, I have an x cubed. Okay, which factors down to x. The x squared minus x minus 2, that factors to x minus 2, x plus 1. Okay, canceling. Okay, I can see that my x plus 1s, okay, they cancel each other out. Uptown, downtown fight there. These x minus 2s over here, they cancel each other out. Okay, right there. Okay, I have an x minus 3, or this x cubed. Okay, they can cross cancel each other out. And what am I left with? Okay, I'm left with an x plus 2 times x minus 1 in the numerator. I'm left with x plus 1 and an x minus 2 in the denominator. And now here's my restrictions. Okay, what can x not equal? I'm just going to come over here and I'm going to point it out. X cannot equal 2. I know the time's out here, but the important part is this last little part. X cannot equal negative 1. Okay, and now here's where you got to watch out for. Okay, what was in the denominator originally? Okay, way up here, this part right here, that has to have a restriction as well. So because this was in the denominator, x cannot equal 1 and x cannot equal negative 1. How do I know that? That came from this part right here. That was in the denominator originally. And then don't forget, x cannot equal 0. Okay, and x, I already have the negative 1 there. So I have 5 restrictions. 1, 2, 3, 4, 5 restrictions, and that simplified part. All right, I see a couple of us bailed out here, but sorry, went a little longer than I want. Okay, hopefully you got everything down there of all the problems that you need to practice, and you have to practice. Otherwise, this is going to be complete misery for the rest of the year. This is an essential topic to you learning for every day from here on out. Practice it well. Come in for help if you need some help. Okay, I will see you on Wednesday. If you have any questions, let me know.
Will you put the answers on like Google Classroom or something?
I will see what I can do. Yeah.
Thank you.
Yep. Alyssa, Eli, questions? Or did you guys fall asleep on me? Elijah? All right, I'll let you keep on sleeping.